Hello everyone. Today we're gonna solve the time needed to inform all employees problem. This is a problem for the crab topic. And to summarize this problem, we have n employees, and with each employee, we will have the manager corresponding to. So we can represent the relationship between an employee and their manager by a graph with a directed edge. For example, if we have the employee I, we gonna have their manager is manager I. And for example, if we have this array, we're gonna have manager of 0 is 2, manager of 1 is 2. So this one is 0, 2, 1, and then uh, the employee to have the manager is -1, which means that he doesn't have any manager. So 23 and so on. We're gonna have a directed graph right here. Yep, and we're gonna have the time to inform their lower rank, which means that the subordination of the each employees by 0, 0, 1, 0, 0, which means that uh, the employee 0, if he informed to his subordination, is gonna cost him 0 time, and for the employee 2, it's gonna cost him 1 time, 1 unit of time. Let's say just 1 minute, right? And they ask us to return the number of minutes needed to inform all of the employees for urgent news. How can we do that? So this is a version, another version of BFS function, BFS algorithm. If we're gonna find the minimum number of minutes to inform all the employee, we just need to adjust the BFS algorithm by using a if instead of just use BFS, because right now we have time as well. So when we have we start with the head ID, which means that the highest ranking employees, and then we're gonna assign the time to him, and we use a min-hif while using BPS algorithm, so that we can find the lowest time. And finally, we just need to check for all of the reaching time from the employees to see which one is the highest one, and that is the time when we need to reach, or when we need to spread the urgent news. So how can we do that? First of all, we uh, need to have a graph, right? Need to prepare the edges for our graph with the manager I to I, and this one is the directed graph. And then next we're gonna use the BFS function, BFS algorithm, start from our head ID. And for step 3, we're gonna have to store the reaching time. Let's say the it's we can call it the receive time of employee. And for example, if we have the employee V, and we have you is his manager, we're gonna receive the new from his manager, right? So the received news time from you plus with the form time of you. So the time, and finally we are gonna get the time needed to inform all the employee gonna be max of all the receive news time right here, right? uh that's the skeleton, and now we're gonna have to implement the whole code. First of all, we're gonna have a adjacency matrix. Adjacency matrix to style graph and have and node. And first of all, we don't have any node for each of the vector, each of the imaginary array. And now we're gonna have to each of what if the I is net ID, uh, just need to bypass this. And if this one is not the highest ranking employees, gonna create match manager and I, right? Have agency uh agency matrix from you, I, and we have BFS two. Actually, we can use Q right here as well because we have a directed the DAG AG uh AG graph. The DAG graph mean that we have the directed acyclic graph, and we don't have any cycle in this graph, and it's from like a sort of like a from one side to the other side, so that we can just use BFS to update all of the value instead of using a heap. It's gonna be easier for us with. So basically, we gonna have vector. Need to have a zero right now, and we start with the F ID, and then gonna do the guess algorithm right here. You can try another function, but actually I master. Yep. And we start by get the element from the front of the queue. Then we pop out, and we look through all of the node in magic, update the receive news time, time, right? And then we time zero at the first place of the if time, if new time, update with time needed. Finally, we turn the time needed here. Right. I think that's all function. And we have the topic for this problem is as you and a little bit of dynamic programming here, but not too much uh, hard to understand. And for the time complexity, of course, it's going to be OV plus E, with V is the number of employee, or the number of node in our graph, and E is mesh. Yep. One is N, I think N minus one. So time complexity for this one, we can redraw it to base complexity, because we uh efficiency matrix a Q is gonna be O plus E for the efficiency matrix, and O V for the and OV for the shift news time as well. So uh to sum up, we have OV plus E dominate. Perfect. That's all for this question. Hope this helped you guys. If you have any question, just leave it below. And if you like this video, just leave a like button, and uh, subscribe for my channel, so that other people can our solution and can solve this problem as well. Thank you.